Yes, dear students, there is one sole example 10.5. This question has been asked 2 or 3 times in board exam. Question says in young double slit experiment using monochrome light of wavelength lambda, the intensity of light at a point on a screen where path difference lambda is k unit. I is k unit, capital K. Where the wave meet with path difference lambda. So young double slit experiment actually again you have to keep in mind this diagram. K point P there and the two waves meet here with path difference lambda. So when path difference lambda, so delta phi equal to 2 pi upon lambda into delta x. If delta x equal to lambda, so it is 2 pi. यानी कि they are meeting in same phase. If light waves starting from S1 S2 which are initially in same phase meet at a point where path difference lambda, they meet in same phase. And we know we have derived this equation for a square k into cos square phi upon 2. In case a1 a2 equal, I have told you I equal to k into a1 square plus a2 square plus 2a1 a2 cos phi. If a1 a2 equal हैं तो we get this equation I have derived many times. If phi equal to 2 pi, if phi equal to 2 pi, then I equal to 4k 4a square into k, जिसको सीधा k कह दिया. Now what is the intensity where he say further, what is the intensity of light at a point where path difference is lambda by 3. What is the intensity in terms of k actually, where path difference is delta x equal to lambda by 3. So delta phi there will be 2 pi upon lambda into lambda by 3 means 2 pi by 3. It means 120 degree. And therefore intensity at that point, this is one I. So let it be I dash. So that will be 4a square small k into cos square 120 upon 2. 120 upon 2, 60 cos 61 by 2. और cos square 60 1 by 4. Cos 60 या cos square 61 by 2 whole square 1 by 4. So it is a square k. Here a square k, ये k है ना, equal to k. तो a square k equal to k by 4. So I dash equal to k by 4. This question is asked to hold by like this. So if here path difference lambda, so intensity is k, and if path difference at any point lambda by 3, if this is lambda by 3, then here it will be k by 4. So intensity generally student remain in confusion कि maximum minimum ही होगा नहीं. At any other point where path difference is not 0 or 2 pi, so intensity naturally will be different. Remember this equation. Now there is another question here. 10.6. 10.6. This chapter of interference is very important and 100% there will be question in board exam and competitive exam. 100% there will be question from this. 10.6 from NCERT book. A beam of light consisting of two wavelengths, lambda 1, 650 nanometer, and lambda 2, 520 nanometer, is used to obtain reference fringes in young double-slit experiment. There, in this book, this data is missing. Small d is there 2 millimeter, and capital D 1.2 meter. 1.2 meter. Here in this book, this data is missing. I have found from somewhere. So in a beam of light consisting two wavelengths 650 and 520 nanometer used interference fringes in young double-slit experiment. Find the distance of third bright fringe on the screen from central maximum. Third bright fringe, 4 wavelengths, 650 nanometer. So first question simple है. We know distance of nth bright fringe from central maximum xn is equal to n lambda d upon d. So x4 is equal to 4 lambda 650 nanometer 10 to power minus 9 meter. Problem is there, here the units are different always. 1.2 upon 2 millimeter, 2 into 10 to power minus 3. So you can simplify it easily. How? Two jar 0, 0, 12 and 13 into 1.2 10 to power minus 6 meter, or this decimal disappear. So 130 into 12 10 to power minus 6, 0, 12, 3 are 36, 3, 12, 150, 15, 10 to power minus 6 meter. Or you can write it as x4 equal to 1.560 into 10 to power minus 3 meter, or 1.5 millimeter. Please develop this skill. This skill will be developed only by doing practice. Only by doing practice. ये एक लाइन गायब हो गई यहाँ. This multiplication is equal to, I am writing here, it comes out 1560 meter. है भाई? तो please solve this now. This is a part of this question. Second part of this question देखो. In young double-slit experiment we have used monochromatic light. कौन सी यूज किया? Monochromatic. But here there are two wavelengths. So just I explained that if we use different colors of light, then central to will always be maximum. So both the wavelength, this one will coincide here, produce central bright. दोनों का bright coincide होगा, इसका भी और इसका भी. But which wavelength will have wider? W is equal to lambda d upon d width. So larger the lambda, greater the width. So जो एक की width थी दूसरी छोटा. तो वो क्वेश्चन यहाँ पर ये है, what is the least distance from central maximum where the bright fringes due to both wavelength coincide? The least distance, the least distance at which the bright fringes coincide again. देखो बात सुनने पर ये विड्थ है इसकी, अब यहाँ पर इसकी डार्क आएगी, इसकी डार्क यहाँ हो जाएगी, एंड सो ऑन दे विल कीप ऑन not coinciding at again certain place. The two will be there, center will be coinciding. What is that? वो कह रहा है the least distance at which the bright fringes coincide again will be the distance of nth bright fringe of lambda 1 यानी कि 650 नैनोमीटर and equal to n plus 1th bright fringe of lambda 2 520 nanometer. Why? Because by this 520 smaller wavelength, their width is small, so their number become one more at least distance. Therefore, I can write here n into lambda 1 d upon d is equal to n plus 1 into lambda 2 d upon d. कैंसिल हो जाएंगे. We have to find out n here. So n into 650 नैनोमीटर मीटर बनाएंगे तो कैंसिल हो जाएंगे, जरूरत नहीं है. Equal to n plus 1 into 520. 13 5 जा 13 4 जा, तो 5n equal to 4n plus 4, n equal to 4. यानी कि the fourth bright fringe of lambda 1 and fifth bright fringe of lambda 2, center of them will coincide again. So we find out x4 equal to xn बराबर, you know the relation x4 equal to 4 into lambda 1 into d upon d. तो 4 into 650 nanometer into 10 to the power 9 into 1.2 upon 2 into 10 to the power minus 3. And you solve it. This calculation again easy here. It is 4 2 ja, so 2 into 1.2 into 650 into 10 to the power minus 6 meter. Into 12, this decimal of 12 5 is 66, 12 is 72, 678 into 10 to the power minus 6 and 0 16 15. उधर पहले निकाल दो x4, तो जहाँ 4th यूनिट होगी ना वो निकाला था हमने यहाँ का, ठीक याद आ गया. So this question is very important. Dear student, has been asked 2 or 3 times in board exam. They may give different wavelengths, but the centers of the two will coincide least distance. Again they will coincide at other distance. Now 10.7. In double slit experiment, the angular width of fringe is found to be 0.2 degree on a screen 1 meter away. It is 10.7. Angular width delta theta 0.2 degree when d is 1 meter. The wavelength of light is 600 nanometer. Now, what will be the angular width of the fringes if entire apparatus is immersed in water of index 4/3? You know delta theta equal to lambda by d. This d has no meaning here. So when apparatus is immersed in water, wavelength of light will change to delta theta dash lambda dash by d to delta theta dash upon delta theta is equal to lambda dash upon lambda. And in our index n equal to lambda upon lambda dash. So it is 1 by n. So delta theta will be delta theta upon n, यानी कि 0.2 upon 4/3. So 0.6 upon 4 equal to 0.15 डिग्री. यहाँ पर डिग्री में है तो कोई प्रॉब्लम नहीं. Such questions are very important for all of you because we remain stuck only with the fringe width. भाई हमें ये तो याद होगा भाई W बराबर लैम्डा d by d, लेकिन वो क्वेश्चन आगे पूछते हैं. अब मैं और बहुत सारे क्वेश्चन करूँगा यहाँ पर. एक क्वेश्चन और है अपने बुक का, दैट इज (10.16). क्वेश्चन इज देयर. NCERT बुक क्वेश्चन है 10.16. व्हाट इज ट्रबल देयर? कुछ है कुछ नहीं. In double slit experiment using light of wavelength 600 nanometer. ये 600 मिलता है आपके पास, यानी कि या कह लो 6 × 10⁻⁷ मीटर. The angular width of the fringe obtained at distance screen 0.1 degree. What is the spacing between two slits? So theta equal to lambda by d. This is given. But theta here is 0.1 degree. 0.1 degree. Lambda upon d meter होगा तो this should be in radian. To convert this theta equal to 1 degree, 0.1 degree into radian equal to क्या होगा? 0.1 into 0.0174 radian. I have told you one time that 1 degree is equal to 0.0174 radian. तो इसको आपने यहाँ पर रेडियन बच्चे बनाना भूल जा और सारा गड़बड़ हो जा. 600 × 7 मीटर 6,000 नैनोमीटर मीन्स इन 10⁻⁹. तो ये अपॉन d निकालना है. तो हियर नाउ d इक्वल टू 6 × 10⁻⁷ अपॉन इट इज 0.0174 मीटर. तो हाउ मच इज दिस? 6/174 into 1 2 3 4 5. तो 10⁻⁻² देगा मीटर. How many millimeter? 60. 60/174 millimeter, because you will multiply 1000. तो 10 हो जाएगा और 60 डिवाइड बाय 170, 4, 0 टाइम पॉइंट लगा 0, 7, 17 3 जा 54, 3 4 जा 12, 50, 51 into 1, 52, 17 3 जा 51 है भाई। तो 8 और here again 7, 0, 16, 17 4 जा 68, 17 5 जा 85, 0.34 you can write like this, or you can write, leave it here. So be very careful whenever you are using angle. You are given in radian, degree, sorry, and we are using this theta, distance upon distance. जब दोनों ही बराबर होंगे तो 1 रेडियन, तो कन्वर्ट रेडियन टू डिग्री प्लीज। थैंक यू। मिलते हैं with more question in coming videos.